Okay, so in this problem we're given the sine of pi by 3 and cosine of pi by 3 and the tangent of pi by 3 is these exact values. We want to show that when we take the definite integral here, that we end up with that. So in order to do it, we have to take the integral. I know if I take sine of x, a positive sine of x gives me cosine, because the derivative of sine is a positive cosine. 2, well, cosine x I know is negative, because if I take the derivative of cosine, I get a negative sign, so I have to counteract that. This one here, minus, well, this is my derivative for tangent, so it's going to be tangent squared. Oh, not squared, just tangent x. Tangent x, and I'm taking these values from 0 to pi by 3. Using the good notation here, we put an on here, so I've taken the integral, so therefore I do not have the integral sign, and I have the values here. Be very careful with your notation. So now I'm just going to plug the values in. So it's going to be sine of pi by 3 minus 2 cosine of pi by 3 minus tangent of pi by 3 minus sine of 0, minus 2 cosine of 0 minus tangent of 0. And so using here, I know this is square root 3 over 2 minus 2 times a half times 1/2 minus the square root of 3 minus, well, sine of 0 I know is 0. Careful, it's going to be plus 2 times cosine of 0 I know is 1. And negative makes a positive, tangent of 0 is 0. So simplifying this all together now, what I can say is if I have these root 3's, I can make this a 2 over a 2. And if I go 1 root 3 over 1/2 minus this will give me a negative root 3 over 2 minus 1 plus 2 ends up with a 1 minus root 3 over 2, which is what I was asked to do. So be careful with your negative signs, use good notation, take the antiderivative, plug values in, using the fundamental theorem of calculus.